Hello, so this is a revision video for AP Chemistry 9.9, Cell Potential and Free Energy. A reduction potential, also called a standard electrode potential, tells us how easily the oxidized species in a half cell gains electrons and gets reduced compared to H+ ions in the standard hydrogen electrode. Standard conditions refer to 298 Kelvin, 1 molar ion concentrations, and 100 kilopascals of pressure for gases. A more positive E value means a greater tendency for reduction to occur, and a more negative E value means a greater tendency for oxidation to occur. The standard hydrogen electrode is used as a reference point and is assigned an E value of exactly 0.00 volts. All this means is that if two standard hydrogen electrodes are connected together, the potential difference between the two would be 0 volts, because reduction takes place just as easily in both half cells. If we now change the right-hand hydrogen electrode for a different half cell, then we now get a potential difference reading between the two half cells. This reading and voltage measured is called the reduction potential of the right-hand side half cell. Reduction potentials are often put into a table called the electrochemical series. So for example, an electrode potential of minus 3.05 volts for a lithium half cell means when a lithium half cell is connected to a standard hydrogen electrode, the potential difference measured is minus 3.05 volts. Standard cell potential, E cell, is the overall potential difference produced by a voltaic cell under standard conditions. It can be used to tell us whether a redox reaction is favorable, where E cell equals E cathode minus E anode. Remember, the cathode is the half cell where reduction happens, so the half cell with the more positive reduction electrode potential, and the anode is the half cell where oxidation happens, the half cell with the more negative reduction potential. Meaning you can also write this equation as E cell equals E reduction minus E oxidation. If the E cell value calculated is positive, the overall reaction is favorable. If, however, the E cell value is negative, the reverse reaction is favored, but the forward reaction is unfavorable. If the E cell value is 0, that means the system is at equilibrium and there is no net forward or reverse reaction overall. We can also link Gibbs free energy change, delta G, to electrochemistry. The E cell value of an electrochemical cell measures how strongly a redox reaction can push electrons through a circuit and drive a current. Standard Gibbs free energy change, delta G, measures how thermodynamically favorable the reaction is, so how much energy is released overall or required in terms of free energy change. The energy available to drive an electric current, so E cell, comes directly from the energy change in the chemical reaction, so delta G. These two quantities are linked by the equation delta G equals minus N times F times E cell, where delta G standard is standard Gibbs free energy change, N is the number of moles worth of electrons being transferred in the half equations, F is something called the Faraday constant, so the number of coulombs of charge per mole of electrons, and E cell is the standard cell potential. For example, calculate the E cell value and delta G for the reaction of zinc plus copper ions to form zinc ions plus copper under standard conditions, with the given half equations and redox potentials. Well, first we need to identify the cathode and anode. Well, here the copper ions are gaining electrons and being reduced to copper, so the copper 2+ and copper half cell is going to be the cathode, and the zinc is being oxidized, so that will be the anode. Well, E cell equals E cathode minus E anode, so positive 0.34 volts minus 0.76 volts gives positive 1.10 volts overall, so that's the E cell value. Now, to find delta G, we need to use delta G equals minus N times F times E cell. Well, the N value here is going to be 2, because in the balanced reaction equation, each mole's worth of copper ions gains 2 electrons, and each mole's worth of zinc atoms loses 2 moles of electrons. So therefore, N equals 2. So minus N times F times E cell will be minus 2 times 96,500 times 1.1, given 212,300 joules per mole. To convert that into kilojoules per mole, which is the standard unit for delta G, that would give minus 212.3 kilojoules per mole. Well, the delta G value is negative, so the reaction is thermodynamically favorable, which we know because the reaction actually happens.